G'day guys, today we're going to be talking about geometric solids. We have a prism on the board, a hexagonal base prism, and the first thing that we've got to realize when presented with a problem like this is that we have been given an auxiliary view. Okay? The way it is presented might be quite confusing, but it is only there to show you what the actual front view looks like and what the top of that front view and the bottom base of this front view really is. So that's the only way I could actually distinguish whether this is in fact a hexagonal based prism. Right, so let's get started. Don't get confused with the fact that the auxiliary view is in this kind of orientation. That is basically, like I said, it's just trying to tell you whether this is a prism and which kind of base it is. We're going to number these corners of the base so that we know exactly what to number or transfer our numbers onto. And once we've done that, basically what we need to do is take this guy and swing it down so that it is upright. So we're going to take the XY axis, the X1, Y1 in this case, and we're going to make it level in line with the XY axis. Alright, so that's as simple as that. Now that we've got this guy here, that we will manage to find this guy in the front view. You cannot find the front view like that without this view over here. So you'd have to reproduce this if the question demands that of you. Right, so once you've done this, I'm going to ignore this now because I've got what I need. And I'm going to give myself an extra or an extension to the horizon line, or horizontal line, at which that point is going to be the pivot point. Right, I also don't need this guy anymore. At the moment I'm going to pivot on that number 4 back down onto this horizontal line. I'll be able to see all those numbers that are going to be projected down onto my XY axis. Okay, if I may, extend this guy here like so, move my X, and let's see. If I put my compass point on my pivot point over here like so, I open it up to 5 and 3. Okay, remember that we do have a cut point or cut line through this object. We're going to ignore it for now. So I'm going to go one step at a time, open up my compass from number 4 to point 5 and 3. I'm going to scribe my arc. I'm going to do the same from 4 to 2 and 6. I'll do this as accurately as I can do it. And then from 4 all the way to 1. Right, please note that I now have point 1 over here, point 2 and 6 over here, and point 5 and 3. Nice and horizontal, and if I want to get that onto my XY axis, I simply drop it straight down onto the XY axis, and now I know that I'm going to have everything in line. Remember what we said in the beginning? We said that we want to actually pick this thing up as though it was untilted. Okay, and then we're going to tilt it again. You'll see in a moment why. So all these are going to be projected straight down. And we know that we're going to have a 10 millimeter difference between my XY axis and the actual shape. And then we're going to look at the orientation. Remember you had your auxiliary view that was placed over here. That auxiliary view basically swung right down to here. I now know between 5 and 6 perhaps, or 2 and 3, I will have a line. I already know that I'm going to be working at 60 degrees. So I'm going to try my best to do this as accurately as possible for the video's sake. That's going to go down to that line over there. That's the distance between these two corners. Know that this is going to be a line, but we know that it's hexagonal. Okay, so I'm going to just simply link that. Know that that's at 60 degrees. And then I'm going to do the same the other way around. Okay, so let's imagine that is an accurate hexagon for the moment, even though it's not. We are obviously just doing this for the purpose of the video and for what you guys are going to be doing on your TV boards. And then we're going to take these and we're going to project them right across to our 45-degree line. Right, once we've done that, we can project that straight up. Okay, now we know the parameters in which my left side view is going to happen. Okay, but now, that doesn't say that my top view is going to look like that, because now it's tilted. So I've got to use this parameter to be able to project all the lines down onto and find exactly what I need. So let's go and renumber this. We know that number 1 happened over here, number 2 and 6. So if I'm going to be having 2 this way, 3 which was on the actual auxiliary view, 5 and 6, then I know when I'm projecting across I've got 2 and 3 over there, number 1 and 4, and number 6 and 5. Now please use the numbers, because the more complex these shapes get, the more or the better I have a visualization to refer to. If I've got numbers to refer to in this view over here, I know that number 1 will be referred to number 1 in any other view that exists, like my front view, my left side view. Okay, so how are we going to go about finding the top view? Well, I know that I've got a bottom base and a top base, and when I look from the top, will I be able to see the top base? Most definitely yes. So when I project that down, I know I'm projecting down number 4. If I line up number 4 with number 4 over there, I know that that point over there will be my top base number 4. Remember, that's the base corner. If I'm doing number 5 at the same time, 5 and 3, project that straight down. I know that 3 is on this line over here, and will collide with this one here. It's an intersection point, so I've got the new base corner 3. 5 the same way. Also 2 and 6, I need to project 2 and 6 right down. 6 is on this side over here, collides with number 6 from the front view over there. Remember, we're doing this orthographic projection, first angle that is, and then obviously number 2 as well. So 2 goes right across, intersects over there. Got number 1, I'll project number 1 right down, and 1 across. I'll have all 6 points to form my top base. Once I've got my top base, theoretically what I'm going to do, let's change the colors a little bit. It looks a little oblong, but that is exactly because it is tilted. Alright, when I look from the top, I'll see my top base like so. Alright, now I've got the top base, I need to connect it to the bottom base, because I've got a 1 all the way around to number 6 at the bottom as well. This here is only going to give me the parameters to work with. So I'm going to go drop number 4 down. Remember, 4 stays where it is. Why? Because it is a pivot point. It stays there. This whole shape pivots on number 4. So it doesn't move left or right. It stays there. So it's going to be at the bottom. 5 and 3, however, when I project that down, I will have number 3. My new point number 3. So 3 isn't here anymore. It's moved. You can see here, that is where it would have been if it was brought upright. Now when it tilts, it actually moves to the right. Okay, so this point has to do exactly the same. From that point, as though it was upright, now moves to the right. And 5 down below the same way. Number 2 and 6, I projected that straight down. 2 now moves as far as that. 2 is now over there. And 6 is over here. And how about 1? 1 has also moved quite a bit. 1 has moved there directly to the right. Okay. So please, don't go and join number 1 over here. That is, these are base corners, and we're joining base corners to one another to form base, the actual base. Okay, so base lines, base edges, that is, to give you a base in total. Right, now that I have the 6 corners at the bottom, I now know that I'm going to literally join, remember, 1 to 1, 2 to 2, 6 to 6, 5 to 5, 3 to 3, 4 to 4, as though it is a solid piece. So I'm going to go take 2 and 3. If I had 3 and 3 joined, and 2 and 2 joined, I'm simply going to extend this line to number 2. And then going to go right around, because 2 and 1 at the base join one another. And then we're going to do the same with 1 and 6. And we're going to do the same with 5 and 5. So it will extend to 5. We'll also have 6 to 6. So I'm simply going to extend that because they're in line with one another. How about number 1 and 1? Passes right through number 4, because 4 is right at the bottom. It'll be in hidden detail. So I'll literally be seeing the hidden detail portion over here. Please do leave a gap over here, because we do not want to extend this existing line into the base area. Otherwise we're changing our shape. Alright, so we've got hidden detail line from 4 to 4. This portion of that hidden detail line is preoccupied by the solid line, which you can see. Okay guys, so that's what my top view would look like. That's going to give me a little bit of an indication as to what my left side view is going to look like. Now please guys, you might notice, it's the same way. If I have an entire bread, I can see the bread, I know exactly where I can cut the bread. But if I haven't got the bread, as though it is in the top view, I don't know where to cut it. Alright, this is what the auxiliary view helped me to find. Okay, a bit of an analogy there. So, if I had to go and find the bread, okay, on the left-hand side over there, when I'm looking over here, from this angle over here, my eyeball, can I see the bottom base, or can I see the top base? From this angle over here, being first angle orthographic projection, I can see the bottom base, but I cannot see the top base. So let's go and do the left side view. From the bottom over here, I can see 1 projected across. See how important the numbers now become? 1 up and 1 across. You give me that guy there. Number 2 and 6, however, is on the same line. Number 2 is found over here. Please draw it on the outside so it doesn't interrupt your line work. And then 6 the same way. Number 5 and 3. 3 and 5. And then obviously your pivot point, which is number 4. Right, because we can see it from this direction, why don't we just go ahead and go and draw it. So there we go. Okay, now that we can see and we've done the bottom portion, let's do the top portion, the portion we can't see. Right, so we know that 1 and 1, let's do the top base. 1 and 1 collects over here. 2 and 2, so we've got far faster now. 3 and 3. On the other side we have 5, this is top base 5, top base corner 2, which is connected to 6, 5 and 6, and then obviously 4 is connected to 4 in the background. Okay, so we know that we see everything, the profile of the actual shape. We have 3 connected to 3, we have 2 connected to 2, so we do that, we follow through with that, the same way 5 is connected to 5. Okay, you don't have to redraw or go over this line again, it already exists, just extend that line over there, and 6 to 6. Profile demands also that we have 1 at the top connected to 2 and 6. If you look at it over here, number 1 is connected to 2 and number 6. Alright, and then obviously we have 1 and 1. From this side over here, you can see 1 and 1 connected to one another. Like so. Right, so now we've gone ahead and drawn the bread we need to cut. There's a bit of hidden detail that we still have to include. 4 and 4. In this case over here, that's what we can't see. Okay, connected like so. 4 is also connected to 3 and 5. So 3 and 5. 4 is connected to, remember now, this is the background, so this is going to go up to 3 and up to 5. Okay, so that's in the back end. That's a surface we can't see. Alright, Now that we can see the bread, let's cut it. The cutting plane ZZ that I have over here, you can see it running from corner to corner. We need to use that now. We need to go ahead and go and find the surface that is cut. Right. So please, in this case over here, you'll always draw the top view as though you can see the cut surface. So will I see the left-hand side, or will I see the right-hand side portion? In this case, I'll see the right-hand side portion. So if you would like, you can fade this out a little bit, make sure that you're not getting this wrong, projecting down the wrong points, and we'll focus on the right-hand portion. What's very important now is to realize that have I got a cut point along 1, 1? At this point, no. My cut line goes through the corner at the top base, and it goes through the corner at the bottom base, 1 and 4. Have I got a cut point along 2 and 6? Yes, I do. That's cut point 2 and 6. Do I have a cut line between 5 and 3, the bottom and at the top? Yes, I do. So I've got to label it 5 and 3. And do I have a cut point along 4 and 4? No, I don't, because we now have to find out that it is cutting through number 4 at the bottom. Okay, so do we have points to project now? Yes, we do. Do we have lines to project it on? Yes, we do. We have point 1 projected down. We know that the cut point is going to start over there. 2 and 6, however, needs to be projected down. Those are new points. Those are cut points. Between 2 and 2, remember, we go between 2 and 2. There is a cut point, 2. Between 6 and 6 is exactly the same. So we go to between 6 and 6, and we find cut point 6. If you want to use different colors just to start off with, and so you can recognize your cut surface, by all means do it. 5 and 3, there's 3 going across. Remember, it's between 3 and 3, cut point 3. And now also 5. Between 5 and 5, I have cut point 5. Okay, and the last one is obviously on number 4. Cut point 4. So what would my surface look like that I'm going to be seeing? Let's just make sure we are finding the right points, or connecting the right points. 4 to 3. 6 and 2. And then from 2, we need to go find number 1. Number 1. Remember, number 1 didn't change. It's still found on that surface over there. So otherwise, let's make this less complicated. Let's erase everything else and see what we're left with. Remember, we're cutting this portion away. This over here is my auxiliary view used to give that portion over there. So now, I'm left with a cut surface looking like so. You would have to cross-hatch that, section it, and then obviously in geometric solids we also include the hidden detail, if there is any hidden detail. This was number 1, and this was number 1. In fact, that was number 4 in the background. Okay, there it is there, and this one here, number 1. So number 4 was connected to number 4. Previously this was a solid line. We've now cut away that portion where the solid line is, and now we can represent the entire line 4 and 4 to bottom base point 4, bottom base point 4 in hidden detail. Let's have a look. Let's double check whether that's correct. Well, if I had to remove this guy, 4 and 4 remains uncut. So that is correct. Okay. So that's what we are going to be left with in our top. That's what our top view would look like. We're only drawing the right side view. Okay, now let's move on to the left side view. What would that look like? Now, they haven't given us a cutting plane over here. Yet, in your question, they show us that there's a cutting plane that goes through the middle of that like so. So I'm going to enter one over here. Please don't get confused. Once I've got this cutting plane, it says, from the angle of the arrow, what do I see? Okay, so now the shape changes a little bit. Remember, I've got ZZ. So this one will be called sectional top view, however, on ZZ. Now, if I had to make this, let's say for instance, B, and this guy over here, B, I'll have a left side view, although it will be then a sectional left side view on B to B. Right, so now this portion over here I can go re-enter as being solid, okay, and also this portion now is going to get cut away. Remember now, between 1 and 1, I have cut point 1. The same thing happens, except we're doing it on that side now. We have our bread, we can cut it. Okay, between 2 and 6 and 2 and 6, and I have a new point, 2 and 6. I'm ignoring Z for that side. Between 5 and 3 and 5 and 3, I've got the exact same point, yet between 4 and 4, I have a cut point 4, which never used to be there because I had ZZ. Now I can go ahead and say, right, between 4 and 4, I project this line across, I have new cut point 4. And the same thing happens all over again. 5 and 3, 5 and 3, cut point 3, cut point 5, between 2 and 6 and 2 and 6. Remember, now we're using this B to B. Use the correct lines, guys. Yeah, so we're going from 2 to 6, 2 to 6, right? Between 2 and 2, I'm cutting cut point 2, and between 6 and 6, I'm cutting cut point 6. Please don't get too confused, right? And then between 1 and 1, I have a cut point on 1 and 1, and not at the top anymore. Okay, so now let's see what we are faced with. We know that 1 connects to 2, connects to 3, connects to 4. So let's follow it. 1 connects to 2, connects to 3. Which 3? Let's follow it carefully. There it is over there. It's all the way down. Connects to 4, connects to 5, connects back to 6, in line with 2, connects back to 1. Question here is, when I look from this side over here, do I see the section surface? In this case, yes, I do. So to make this less complicated, the front portion is the one that goes away. Okay, so let's not try and erase things that we shouldn't erase. It's just going to go take the solid parts away. Okay, would you see anything over here? Well, do we see that portion over there? Let's project it. Remember, we've cut it away now, so this portion is what's cut away. I have to take this away completely. Now my object is going to start between this and that point there, which is my cut surface, but it's actually going to go all the way from the top down to that point, which is projected. So I'm not going to see this point over here. That's all gone. You can leave it in construction. Remember the bread that you guys have made. And now that I've got the surface, remember the 6 corners of my surface. I'm going to cross hatch it in 45 degrees, equal intervals, guys, please. Oh, not like mine. Okay, and you'll still leave the hidden detail in the background. Alright, that is what you will see as your left side view. Right, guys, please note that you still have to show exactly what your back end would look like. You still have to include your hidden detail, and that is going to obviously be your sectional left side view on B.